Mars is famous for its dusty, red surface. From orbit and on the ground, the planet almost looks monochrome. There are endless shades of rust, orange, and brown. But recently NASA's Perseverance rover came across a very interesting-looking rock on Mars. It looked like the coat of a zebra with alternating black and white stripes. The rock was unlike any seen by any of the rovers or previous landers on Mars before. Also, the rock looked out of place as it was sitting all by itself with no other similar rocks in the area. So, how did the rock form, and how did it get there? The rock was discovered while Perseverance was traveling along a relatively flat stretch of pebbly terrain as it was slowly climbing up the rim of Jezero crater. The crater is an ancient lake bed that Perseverance has been exploring since 2021. When Perseverance spotted the unusual textured rock, even from a distance it looked unusual in the lower resolution Navcam cameras. The rover then moved closer and used its Mastcam Z camera to get a better look. The rock itself was basically oval-shaped and only about 20 centimeters long, but it offered some intriguing hints. On Earth, rocks with banding form only under specific conditions. This made the Martian find intriguing. While the knowledge of the chemical composition of the rock is limited, scientists think that igneous or metamorphic processes could have formed the rock. Igneous rocks form when molten rock, magma or lava cools and hardens. If magma cools slowly beneath the surface, different minerals can crystallize at different times. This process can create layered patterns. Lighter bands are made of certain minerals and darker bands of others. If the rock formed this way, it suggests slow cooling beneath Mars' surface long ago. Scientists know volcanic activity shaped Jezero crater. Perseverance has found volcanic rocks before, showing Mars once had an active interior. The striped rock may fit that story. Another possibility is metamorphism, which suggests that the rock might be a type of metamorphic rock with similar kinds of stripes. On Earth, metamorphic rocks form when existing rocks are changed by intense heat, pressure, or reactive fluids, such as hot mineral-laden water. This can cause minerals to separate into layers and create dramatic striping. Mars doesn't have plate tectonics like Earth. However, it has experienced powerful impacts and localized heating events. Those forces might have transformed rock deep underground. Regardless, the stripes hint at a more complex geological process than the surface reveals. But why was the rock all by itself? Most of the surrounding terrain in Jezero crater is basaltic. Basalt forms from rapidly cooled lava and usually looks uniform. It doesn't typically have bold, alternating bands like the rock does. NASA said since it is a loose rock and clearly different from the underlying bedrock, it likely originated from somewhere else and was somehow deposited at its current location. Perhaps it may have rolled downhill from higher up on the crater rim, or it had been displaced by ancient impact forces. It's possible that the impact that created Jezero billions of years ago blasted material from deep beneath the surface and scattered it across the area. The rock is merely the latest in a series of intriguing rocks found recently. Ever since arriving in the vicinity of the crater rim, NASA scientists have noticed an increased variety of rocks. These diverse rocks could be the first glimpse at ancient rocks uplifted from depth by the Jezero impact, now exposed on the crater rim. Mars today appears quiet and cold, but billions of years ago it was far more active. There were volcanoes, flowing water, and dramatic impacts reshaping the surface. Rocks like this one act as time capsules, preserving evidence of those ancient processes. They could help scientists study layers of Mars that are otherwise hidden. Scientists are hoping that Perseverance will find more rocks like this as it continues to climb higher up the crater rim and collect samples for a future return to Earth. Detailed laboratory testing may eventually reveal the exact mineral composition of rocks like this. It could answer questions that rover instruments alone can't resolve. Until then, Perseverance is leaving no stone unturned.